Good morning. Good morning, ladies and gentlemen. This morning, I will be looking at this particular question. Here is the question: if y equals to 2x squared plus 1 all over 3x squared minus 2, find the y over the x from first principle. At first, as simple as ABC, I'm going to teach you and break down how to use first principle to tackle this type of questions. I know people always find it difficult, but after this video, you thank me. And make sure don't forget to like and share. It's okay. So, ordinarily, if we want to differentiate y equals to 2x squared plus 1 all over 3x squared minus 2, we are supposed to use quotient rule, two of us. And quotient rule is dy all over dx is equals to v du all over dx minus u dv all over dx all over what? V squared, right? So we now see let u be equals to the numerator 2x squared plus 1, 2x squared plus 1, and v be equals to 3x squared minus 2. So what we need to do, we differentiate the u all over dx equals to, we differentiate this function to give us 4, right? 4x, sorry. And differentiate this function to give us the v all over dx equals to what? 6x. True of course. Yeah, it's true. Amen. Okay, so we have to substitute this, and this into this formula. That is our dy all over dx is equals to, ordinary v is this 3x squared minus 2. Then du all over dx is what? Times 4x minus open bracket, ordinary u is 2x squared plus 1, then dv all over dx is 6x, amen. Then all over v squared, right? All over v squared, which is v is 3x squared minus 2 open bracket raised to the power of what? 2. This is what you are supposed to have. Yeah. This is what you are supposed to have. So, that is after using first principle. This is what you are supposed to have. So, I'm going to teach you how to use first principle to differentiate to obtain this answer. Is that clear? So let's write it somewhere else. Let us write this answer somewhere else. Let me write it below here so that we'll compare dy all over dx is equals to open bracket 3x squared minus 2 times 4x close bracket minus open bracket 2x squared plus 1, then open bracket 6x all over 3x squared minus 2 all in what? Square, right? Okay, so let's leave it like that. Then go ahead to use the morning, Salmatu. How are you? So let's proceed. Let me teach you how to use first principle. Let me teach you how to use first principle. So now they said we should use first principle. So let's write solution. y is equals to 2x squared plus 1 all over 3x squared minus 2. The first principle is 1 plus dy is equals to the formula, open bracket, x plus dx, right? It's okay. So far so good. It implies that, I told you that when you have 2x squared plus 1, let us say you have 2x squared, compared with this f of x plus dx, right? So it means your constant there is 2, right? Then this is your f. Now why this your x is x plus dx? So this is how it will be, 2 open bracket, but note that x carries power. Open bracket, x squared dx raised to the power of what? 2. Exactly. So anywhere you see x, you substitute in x plus dx. But if it is squared or it has a power, don't forget to put the power. Is that clear? But if there is no x, there is no need, you just leave it like that. So let's proceed. Amen. Let's proceed. So here, looking at it, y plus dy will now be equals to, we have 2x squared, right? So here will be 2 open bracket, what? X plus dx, then raised to the power of 2 plus 1, right? Because 1, the x is not attached to this one, so there is no need to just write the 1. Then all over, what do you have, the 3x squared? So write 3, because 3 is your f. Right, instead of x, we write x plus dx raised to power what? 2 minus 2. Yeah. So that is that. Let's proceed further. So now we need to expand these brackets. Is that clear? We need to expand this bracket by using Pascal triangle, because we know that when we have x plus dx all is squared, this is the same thing as what? X plus dx open bracket times x plus dx, right? Two of us, but this will take us time. So what we need to do, 1, 1, 1, prepare a Pascal triangle. 1 plus 1, 2, right? 1. So it means it is raised to power 2, right? 1, 2. So this is what we need. So we just need 1, 2, 1, right? So far so good. So here will be y plus dy equals to 2 open brackets. When we expand this bracket, we are going to have 1, 2, 1, right? That is x raised to power 2, then plus 2x dx. I'll make another video on how to use Pascal triangle. Is that clear? Plus dx squared, close bracket, plus 1, all over the same thing applicable, 3 open brackets, x squared plus 2x dx, then plus dx squared, close bracket, minus 2. Amen? Are you following? Okay. So far so good. So if you can see what I am saying, you don't need a prophet to tell you. Okay, you don't need a prophet to tell you. Amen. You don't need a prophet to tell you. So, what we need to do, we have to subtract y from both sides. Where we subtract y, we'll be left with dy equals to, let's open this bracket at once, then We are going to 2 times x squared, 2x squared, 2 times 2x dx plus 4x dx, 2 times dx squared plus 2 dx squared, then plus what? 1 all over the same thing applicable, 3 times x squared, 3x squared, 3 times 2x dx, 6x dx, 3 times dx squared plus 3 dx squared minus 2 minus y, right? You gotta put it inside the bracket. Then our dy will now be equals to 2x squared plus 4x dx, hope you are following, plus 2 dx squared plus 1 all over 3x squared plus 6x dx plus 3 dx squared minus 2 minus y is what? This. So 2x squared plus 1 all over 3x squared minus 2. Amen? Yeah. So at this point, you know, when you come across something of this form, you don't need a prophet to tell you. Assuming you have A all over B plus C all over D. You look for what? LCM. The LCM is B and D. So B, D, then, yeah. Is that clear? Or you cross multiply. Use this to multiply this, use this to multiply, then multiply them. So we use 3x squared minus 2 to multiply this 2x squared plus 4x dx plus 2 dx squared plus 1. Then use 3x squared plus 6x dx plus 3 dx squared minus 2 to multiply 2x squared plus 1. Then use this denominator to multiply each other. That is what I want to do. Is that clear? Take it. So our dy will now be equals to 3x squared minus 2 times 2x squared plus 4x dx plus 2 dx squared plus 1. Amen? Then minus open bracket 2x squared plus 1 times 3x squared plus 6x dx plus 3 dx squared minus 2. Then all over this times this, right? The denominator. 3x squared plus 6x dx plus 3 dx squared minus 2, close bracket, then times 3x squared minus 2. Yeah, look at the board, everybody. Savior. Hope you guys are following. Okay. Please, I want you guys to like. So far, so good. So, this is what we are going to do. So, at this point, what you need to do is for you to what? Divide through by what? X. Sorry, dx. You divide through by dx. Is that clear? You divide through by dx. Divide through by dx. So when you divide through by dx, then you take limit. So now we now write divide 2 by dx. Here will be y all over the x is equals to, it will only affect this numerator, it will not affect the denominator. Take note, is that clear? So this is how it will be. 3x squared minus 2, open bracket, 2x squared plus 4x dx plus 2 dx squared plus 1, then all over the x, all over what? The x, right? Then minus open bracket 2x squared plus 1 times 3x squared plus 6x dx all over dx, right, plus 3dx squared all over dx minus 2, close bracket. Then all over, you know, I told you the division will only affect this, so you write back this 3x squared plus 6x dx plus 3dx squared minus 2, close bracket, times 3x squared minus 2. Do you agree with me? Yeah. Okay. So if you agree with me, let me take out this part. Okay, so if you agree with me, this and this will cancel, right? Okay, let's look at it together. This and this cancel, this and this will cancel, right? Okay. Then this and this will cancel, right? Okay. We have 2x squared dx oh, I think I want to make a mistake. Yeah, let's okay, after multiplication, this is what we are supposed to get, right? Yeah. 2x squared 4x dx plus 2 dx squared plus 1, right? Okay. So far, so good. So here, too, supposed to be yes, right? Okay. Yeah, let's Okay, so our dy, sorry, okay, dy over dx, our dy over dx will now be equals to 3x squared minus 2 open bracket. We are going to have 2x squared plus 4x coming plus 2 dx plus 1 minus 2x squared plus 1 and 3x squared plus 6x plus 3 dx minus 2 and all over 3x squared plus 6x dx plus 3 dx squared minus 2 open bracket 3x squared minus 2. Okay, let's look at it. Preserved. Good morning. How are you? Where are you watching from? Okay. Let's look at this together. Let us look at it together. Amen. 2x s squared plus x dx. Yeah. So I think here we are supposed to have the x. The x, yes. It's supposed to be the x. The x, right? Dx, dx. So here will be 0, 0, right? And here too is 0, 0. So our dy all over dx is equals to 3x squared minus 2 open bracket. Here is 0 because of 2x over dx. Then 4x plus 2 dx. Here is 0 because 1 over dx. Then minus open brackets 2x squared plus 1. Here is 0 because of 3x squared dx. Then 6x plus 3 dx. Then here 2 is 0 because of 2 all over dx. Then all over 3x squared plus 6x dx plus 3 dx squared, amen, open bracket, minus 2, right? Minus 2 times 3x squared minus 2. So at this point, what are we going to do? We introduce limit, right? As limit, the x tends to what? 0. Is that clear? So the whole thing now be our dy all over the x now be equals to, anywhere you see the x is substitute, you write 0, 3x squared minus 2 and 4x plus 2 open bracket 0 close bracket because of the x minus 2x squared plus 1, then open bracket 6x plus 3 times 0, then all over 3x squared plus 6x open bracket 0, because the x is 0, right? Then plus 3 dx squared, right? 0 squared minus 2, open bracket 3x squared minus 2, right? So far so good. Our dy all over dx is equals to 3x squared minus 2, then times 4x, 2 times 0 is 0, minus open bracket 2x squared plus 1, 3 times 0 times 6x, then all over 3x squared 0 0 minus 2 times 3x squared minus 2. True or false? Then you can now see that. Can you see? This and this, they are the same thing. So this is how to use first principle and solve this type of questions. So thank you for your time. I love you guys. Bye. Have a wonderful day and weekend. It's okay.